proper. And chemistry was discovered firstly by Cavendish, and the name was Leviosa that gave it the name hydrogen. Hydrogen was discovered by who? Cavendish. And the name was given by Leviosa. And what's the meaning of the word hydrogen? Hydrogen means water producer or water former. Thank you. We would like to be extensive in our studies. Chiefly, I would like you to see, because I'll be talking on activity series. And one of it is this. That's the order. This is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper. These gold at the base. Silver. Mercury. And then this is hydrogen. Now take note, this hydrogen, and it has isotope. We have the normal hydrogen, which is called what? Protium. Normal hydrogen is called what? Protium. We have as protium. We have deuterium, which is called heavy what? Hydrogen. You know deuterium reacts with deuterium. We have the deuterium. This is radioactive. This one is what? Radioactive. This one forms D2O, heavy hydrogen. This is the normal hydrogen. This one is radioactive. Now, the laboratory preparation of hydrogen. You know, each acid has hydrogen. Each acid has what? Hydrogen. So if you use most of these reactive metals at the apex, those ones that are higher than hydrogen in the activity series will replace hydrogen from any acid. For instance, zinc. Zinc will replace hydrogen. Now, when you dissociate hydrogen, chlorine, this the zinc is reacting with, zinc will displace the hydrogen, and it will form zinc chloride, and hydrogen gas will be displaced. So you can form hydrogen from what? Displacement of hydrogen from an acid. Thank you. You can also, the action of iron is also a metal, which is higher than hydrogen. The activity series can always displace hydrogen from the acid. Now let's go on for the purpose of our class. I would like you to know too that hydrogen is also removed through upward delivery eventually. Industrial preparation of hydrogen from water gas. The process is called Bosch process. For the purpose of our jam, Bosch what? Process. Bosch process. We obtain hydrogen. Okay, I briefly wrote down the activity series. There is zinc. Zinc is here. Zinc is here. And don't forget that any acid must have hydrogen in it, and that any metal that is higher than hydrogen in the activity series must displace what? Hydrogen. Are you getting that? Okay. Physical properties of hydrogen. Pure hydrogen is colorless, odorless, and what? testless. Pure hydrogen is what? It's also neutral to litmus paper. Okay. I would like us to test for hydrogen. It makes a pop sound. When you expose it to a glowing splint, it makes what? Hydrogen makes what sound? A pop sound. A glowing splint, if you introduce hydrogen gas to it, it will make a pop sound. Thank you. So can we answer some of the Jamb and wire question? Question number 1. Which of the following oxide can be reduced by hydrogen? Question is, which of the following oxide can be reduced by hydrogen? Which of the following oxide can be reduced by hydrogen? Don't forget, I told you beforehand of the activity series, and I told you that every metal that is higher than hydrogen in the activity series will displace hydrogen from a compound. Are you hearing me? So, from this option, we have aluminium oxide, magnesium oxide, sodium oxide, silver oxide. Watch the metals. Of all these, sodium is the... Of all these, which of the following oxide can be reduced by hydrogen? So, hydrogen cannot reduce sodium because sodium is higher than hydrogen that is in this series. Are you hearing me? Hydrogen cannot what? Reduce magnesium, remove oxide from magnesium because magnesium is higher than hydrogen in the activity series. Aluminium is also higher than what? Hydrogen in the activity series. Silver is the only one below hydrogen in the activity what? Series. So hydrogen can always displace or reduce silver. That's why silver is the option. Did you hear that? The next question. The most important use of hydrogen is in the what? These are the uses of hydrogen, but there are uses that are more important. Manufacture of ammonia, manufacture of methyl alcohol, manufacture of ethyl alcohol, hydrogenation of oil. Take note, the manufacture of ammonia is the most important. That is through the process called what? Haber process. Did you hear that? Through a process called what? Haber process. Yes. Now, the third question is this. Hydrogen is readily released when dilute hydrochloric acid reacts with which of the following? Hydrogen is readily released when dilute hydrochloric acid reacts with A. Copper, B. Sodium, C. Gold, D. Silver. Take notes. I told you that metals above hydrogen in the activity series, they are going to displace hydrogen from any acid. Are you hearing me? Now, copper is below hydrogen, it cannot displace hydrogen. Sodium is above hydrogen, so it can displace hydrogen from any compound of an acid. Gold is lower in the activity series. It cannot displace hydrogen. Silver cannot. So the right answer is what? Sodium. Which of the following represents an industrial preparation of hydrogen? Well, these are various ways hydrogen can be preserved, can be prepared, but the commercial form of preparation from this option is the reaction of coke plus, that's carbon plus H2O, give you carbon 4 oxide and hydrogen gas. So this is the correct answer. Thank you. Can I go? Hydrogen is used in oxyhydrogen flame for melting metals because it A. evolves a lot of heat when burnt. B. combined explosively with oxygen. C. It's a very light gas. D. It is rocket fuel. The reason is this: it exudes a lot of what? Heat. So that's the answer for now. Thank you. Take note. The next question, please. You should write down. The oxide that remains unchanged when heated in hydrogen is the oxide that remains unchanged when heated in hydrogen is A. Copper oxide, that is CuO. B. Fe2O3, that is hematite. C. Lead oxide and zinc oxide. Now from this option you were asked which of them Okay, which of them will remain unchanged? The oxide that remains unchanged when heated in oxygen is, look at these are various oxides. When heated in oxygen, the oxide that remain unchanged. Here, copper oxide, iron oxide, lead oxide, zinc oxide. The answer is iron oxide. Next question. Hydrogen gas is not found in nature because it readily reacts with, I repeat, hydrogen gas is not found in the atmosphere because it readily reacts with A. The first option is nitrogen, second is carbon 2 oxide, 3 oxygen, nitrogen 4 oxide. So among this option, which one do hydrogen react with? Why is it that hydrogen is not found free in air or in the atmosphere? It's because hydrogen reacts with what? Oxygen. So the right answer is oxygen. That's why hydrogen, you can't find it freely in air. It's highly reactive and it reacts with what? Oxygen. Now, the next question is this. Which of the following metal will react with cold water to produce zinc gas? Which of the following metals will react with what? Cold water to produce. Number 2 here is calcium. The third one is copper. And the fourth one is what? Magnesium. So I repeat the question. Which of the following metal will react with cold water to produce hydrogen gas? Look at, from the activity series, most reactive metals, metals that are highly reactive, they can react with cold water to liberate hydrogen. Some of them you need to heat the water. Are you hearing me? Like iron. It must be red hot. Iron must be red hot for it to what? Evolve hydrogen. But for these that are highly reactive, among these that are in the activity series, you notice that calcium is higher. Calcium is higher in the activity series. The rest are lower. Aluminium, look at it here. Magnesium is here. And copper down there. So the one that liberates hydrogen is calcium. Thank you. The next question. An isotope of hydrogen commonly refers to as heavy water is what? An isotope of hydrogen commonly referred to as heavy water. A, we have protium. B, we have deuterium. C, we have tritium. D, we have basic water. Which of them? Deuterium, thank you. The next question. Hydrogen is manufactured via the following method except action of steam on iron, action of steam on red hot coke, action of steam on methane under nickel catalyst, electrolytic method. So which one is not the option? Action of steam on red hot coke. All except one metal can displace hydrogen from water or acid. Which of the options will displace hydrogen from water? So I repeat the question again. Which of the, all except one metal can displace hydrogen from water or acid. All except one metal from this option can displace hydrogen from the acid. We have zinc, we have silver, we have potassium, we have heated magnesium. So which one is lower than hydrogen in the activity series? Where is silver? The Did you see that silver is underneath? Silver is lower than hydrogen. So it cannot liberate hydrogen in the activity series. So the answer is what? Silver. The rest can liberate hydrogen in the activity series. Oxidation state of hydrogen in the hydride of nitrogen is, what is the oxidation state of nitrogen? Or we'll leave that for when we are on observation, please. The next question is this. Okay, please write. I would like to write down the question. Iron oxide reacting with hydrogen. Now, from this equation, you are asked, hydrogen behaves as what? Hydrogen behaves as what? A, an oxidizing agent. B, a reducing agent. C, steam donor. D, hydrate. So hydrogen behaves as what? Look at hydrogen. Watch. This is hydrogen. So, did you see hydrogen here? Did you see it acquired oxygen? Did you see that it removed the oxygen in ion? So, it takes a reducing agent to remove oxygen from a substance. It takes what? To remove oxygen. So, a reducing agent is always oxidized. Did you see? It will reduce, so it will do its work of reduction, but finally it will be oxidized in itself. So hydrogen acts in this equation. Hydrogen is acting as what? A reducing agent. Thank you. I think that is that for oxygen. Can we go? Alright, that's that for hydrogen. Let's talk about oxygen. Okay. Let's talk about oxygen. It's reactive and most times it's in a molecular form O2. It's a gas. You've heard before ozone. These are the basically two forms you see them in nature, but most of them are in O2. This is ozone. Thank you. Oxygen. The name oxygen means what? Acid producer. In the previous class, we said that hydrogen is what? Water what? Producer. And oxygen is what? Acid producer. Thank you. We can obtain oxygen from hydrogen peroxide. Hydrogen peroxide, H2O2. We obtain oxygen from it. There are other methods: decomposition of potassium triacylchlorate 5, and also oxidation of hydrogen peroxide. Thank you. Industrial preparation of oxygen. Oxygen may be prepared industrially by what? Electrolysis of water. Oxygen is prepared industrially by what? Okay. Physical properties of oxygen. Physical properties. Properties of oxygen. Number one is that oxygen is colorless, tasteless, and odorless, neutral to most litmus paper, and is slightly soluble in water. Test for oxygen. Now, the cardinal point is the difference from oxygen and what? Nitrogen 1 oxide. The difference between oxygen and what? Nitrogen 1 oxide. Under the test of oxygen, you know oxygen rekindles a glowing splint. Nitrogen 1 oxide also what? Rekindles what? A glowing splint. But the difference is when oxygen reacts with nitrogen 2 oxide, oxygen evolves a brownish color gas, a reddish brown color gas. But nitrogen 1 oxide will not react with what? Nitrogen 2 oxide. Nitrogen 2 oxide, when it reacts with oxygen, it gives us what? Reddish brown color gas. But that of nitrogen 1 oxide does not react with what? Show no visible product with nitrogen 2 oxide. What? Heated copper. When you introduce heated copper to nitrogen 1 oxide, when heated copper is introduced, nitrogen is released. What is released? Nitrogen is released in the process. But that of heated copper on oxygen, there is no release of nitrogen. That is the difference. When you're testing for oxygen, it rekindles a glowing splitter. That is, oxygen encourages burning. But even nitrogen 1 oxide also rekindles what? A glowing splint. But the difference is that when you introduce nitrogen 2 oxide, what happens is that oxygen reacts with nitrogen 2 oxide to evolve reddish brown gas, while nitrogen 1 oxide do not show any notable reaction with nitrogen 2 oxide. Now, when you bring forth heated copper, you will notice that nitrogen 1 oxide reacts with what? Heated copper, and nitrogen gas is what? Evolved. But when you bring in hot or red hot heated copper, there's no visible reaction with oxygen. Thank you. Let's talk about oxide. Oxide. There are different types of oxide. We have acidic oxide. We have basic oxide. Which other oxide? Neutral oxide. Amphoteric oxide. Right? So what are basic oxide? Basic oxide are oxides of what? Oxide. We have basic oxide, acidic oxide, neutral oxide, and amphoteric oxide. Basic oxide example is what? Basic oxide are oxides of what? Metals, right? Basic oxide are oxide of metals. You know, when they react in water, they behave like what? A base. That's why we call them basic oxide. When these oxides, when they react in water, they behave as what? Base, because they form hydroxides. Now, sodium oxide is an example. Magnesium oxide is also an example of basic oxide. Calcium oxide, copper oxide, potassium oxide. Take note. Acidic oxide is the oxide of non-metals. Acidic oxide is the oxide of what? Non-metals. Examples are CO2, SO2, NO2, SiO2, that is quartz, that is sharp sand, SiO2, and P4, that is phosphorus, P4O10. We have neutral oxide. They are neither acidic or what? Basic. They are neither what? Acidic or basic. We have CO, H2O, H2, N2O. Amphoteric oxide, they are oxides that have both acidic and basic properties. They behave as acid and they have also the potency to behave like a base. So example is aluminum oxide, zinc oxide, lead oxide, and tin oxide. Now let's talk about uses of oxygen. Oxygen is used as source of breathing, right? It's used in production of flames, right? Also in the production of flames, and it can be used in steel industry for the removal of carbon, sulfur, and what? Phosphorus. It serves as liquid fuel for rockets. Ozone. Ozone is unstable, that is O3. Ozone is what? O3. Found in the atmosphere is unsuitable. But before then, I would like to talk briefly while we round up on the different forms of oxide. We have hydrogen peroxide, H2O2. We have nitrogen peroxide, N2O2. Okay. These oxides are useful. Like hydrogen peroxide is used as antiseptic. Hydrogen peroxide is used as what? Antiseptic. Take note. Hydrogen peroxide is also a bleaching agent. Hydrogen peroxide is also what? Other ones are what? Chlorine. Chlorine bleaches by oxidation, and SO2 bleaches by what? Reduction. So, hydrogen peroxide also bleaches by oxidation. Thank you. Hydrogen peroxide is used in bleaching soft materials. It's used in bleaching what? Soft materials, like the skin of a human being. Chlorine is very harsh, and SO2 is also very harsh. So, hydrogen peroxide bleaches by oxidation. Chlorine bleaches by what? Oxidation. And SO2 bleaches out by reduction. Take notes. Okay. So what's the formula for laughing gas? What's the formula for laughing gas? N2O2. Thank you. The formula for laughing gas is what? Okay. What is allotrophy? What is the allotrophy of oxygen? Ozone. That is O3. The allotrophy of oxygen is what? Ozone. So what's allotropy? Allotropy is the ability of an element to exist in more than one form in the same physical state. Now there are questions here I would like us to answer. The most abundant element on Earth is A. Nitrogen, B. Helium, C. Silicon, D. Oxygen. Or this, let me put it this way: the most abundant element in the atmosphere is nitrogen. Nitrogen is the most abundant element in the atmosphere, right? It is 78%. Can we go on? Which of the following which of these reactions with oxygen is slowest? Rusting, petrol and oxygen, coal and oxygen, iron and oxygen. Which one is the slowest? Rusting, petrol and oxygen, iron and oxygen, coal and oxygen. The slowest is what? Rusting. The slowest is what? And take note, rusting can only take place in the presence of water. There must be moisture and air for rusting to do what? Take place. The next question. Which one is an amphoteric oxide? Which one is what? An amphoteric oxide. SiO, that's a quartz, calcium oxide, potassium oxide, aluminium oxide, copper oxide. Which one is amphoteric? Yes, aluminium oxide is what? Amphoteric. Okay, good. Which of these is not an amphoteric oxide? Zinc oxide, tin oxide, aluminium oxide, sodium oxide. Yes, sodium oxide is not what? Sodium oxide is not amphoteric. I told you that examples of amphoteric oxide are what? Aluminium oxide, zinc oxide, lead oxide, and tin oxide. So sodium oxide is not what? Amphoteric. Thank you. Which of these oxide occurs in snow, dew, air, and water when exposed to brilliant sunlight? Which of these oxide occurs in snow, dew, air, and water when exposed to brilliant sunlight? A. Potassium oxide. B. Hydrogen peroxide. C. Lead oxide. D. Iron oxide. The answer is hydrogen peroxide. Hydrogen peroxide exists where? In snow, or dew, or air and water that is exposed to sunlight. Thank you. Air can be absorbed by passing it through what? A. Caustic soda. B. Fused calcium chloride. C. Alkaline pyrogorel. D. 95% ethanol. E. Washing soda. The answer is what? Alkaline pyrogorel. Take note. The question is, oxygen in air can be absorbed by passing it through what? Alkaline what? Pyrogorel. Next question. Which of the following pair of elements forms amphoteric oxide? Zinc and aluminium, sodium and potassium, silicon and lead. Zinc and aluminium forms what? Amphoteric oxide. Thank you. Oxygen can be prepared in the laboratory by heating which of the following? Oxygen can be prepared in the laboratory by heating. Oxygen can be prepared in the laboratory by heating which of these? Now the answer is potassium chlorate. You heat it, oxygen will be produced. Next question. The following oxide reacts with water except A. Sodium oxide. Okay, let me give you the options. The following oxides react with water. Water except the one that does not react with water is copper oxide. And that is that on oxygen, please. Let's go on halogens. Halogens are members of the group 7 in the periodic table. The word halogen, the actual meaning of halogen is salt formers, right? Salt formers, we have a fluorine, which is the most reactive. The halogen fluorine is the most reactive. After fluorine is what? Chlorine. Then bromine and this reactive is what? Halogen. Take note. This reactive is what? Iodine. Thank you. Let's talk about chlorine, please. Preparation of chlorine. Chlorine, you know, the halogens, they are strong. They are strong oxidizing substance. This one, the strongest of all is what? The fluorine. Then the what? Chlorine. And because of the strength of their as a strong oxidizing substance, to test for them you use a reducing agent. To test for any of these things, if you have to test for any of them, you use reducing agent because they are strong oxidizing agents. Thank you. Laboratory preparation, we can get that from manganese 4 oxide. It's one of the laboratory the way we prepare chlorine. Industrially, we can get them from the electrolysis of brine. Brine is sodium chloride found in cereal. Sodium chloride, electrolysis of brine. From there we can obtain chlorine in large quantity. We can also get chlorine from molten sodium chloride or magnesium chloride or calcium chloride. Take note of this point. Chlorine is then liquefied after the preparation and is stored under pressure in a steel cylinder. Chlorine is stored where? In a steel cylinder. Okay. One remarkable feature or property of chlorine is that it is poisonous and it can destroy the lining of the lungs. Are you hearing me? Chlorine is poisonous and can destroy what? The lining of the lungs. Chlorine, the color is what? Greenish yellow. What is the color of chlorine?
Greenish yellow.
And which unpleasant choking smell. Thank you. Okay. The chemical properties of chlorine, one of its features is that chlorine reacts with metals. This hydrogen chloride. And take note, chlorine reacts with group 1 metals to form electrovalent bond. Chlorine reacts with what? Example, sodium. To form what? Ionic bond. The reaction between hydrogen and chlorine is covalent bond. Take it. To what? But when chlorine reacts with group 1 or group 2 metals, this group 2. This group 2 metal, right? This group 1, right? When you react with this one, the kind of bond formed is what? Ionic. But when you react with like in hydrogen now, this is a typical example of covalent bond. Now, what kind of bond is this in ammonium? Ammonium chloride is dative covalent bond. In ammonium chloride is what? Dative covalent bond. Thank you. The bleaching property of chlorine. Why do chlorine bleach? When you pour it in water, you know it bleaches by what? How do chlorine bleach? Bleaches by oxidation. Now this is dye. Why is chlorine able to bleach substance when it's in water? Now, chiefly at the end is going to release oxygen. You know, we say that it bleaches by what? Oxidation. So the presence of oxygen will wipe out any dirt or dent on the substance that it wants to bleach. Thank you. So chlorine bleaches by what? And the SO2 bleaches by what? Thank you. Now, the formula for bleaching powder. Formula for what? Bleaching powder. So that's the formula for what? Bleaching powder. Thank you. Okay. Test for chlorine. Test for what? Chlorine. If you use a damp litmus paper, chlorine turns what? Blue litmus paper how? Red. And if you use starch iodide, chlorine turns it what? Blue black. This chlorine, this potassium iodide. Are you hearing me? So chlorine turns starch iodide to what? Blue black. The blue black is because iodine is liberated. The blue black color is because what? Iodine is liberated. Thank you. Chemicals like hydrogen chloride. Chlorine is used in making chemicals like what? Okay. Chlorine is a very good bleaching agent. Used in the bleaching of substance as well. Part of chlorine. One of it is hydrogen chloride. Hydrogen what? So one of the tests for hydrogen chloride is with ammonia. When you add hydrogen chloride to ammonia, substance, you will notice a dense white foam of ammonium chloride. You will notice what? Dense white foam of what? Ammonium chloride. If you test with silver triazonitrate, you're still going to notice what? White precipitate. White what? Precipitate. Okay, that test can also be carried out with silver, with lead 2 triazonitrate and silver triazonitrate. Take notes. Test for hydrogen chloride, we said if you use ammonia, what will it form? A dense white foam of what? Ammonium chloride. A dense white foam of what? A dense white foam of ammonium chloride. Now, if you use silver nitrate, it will still give you what? White precipitates. Or you use lead 2 triazonitrate, it also gives you white precipitates. Take note of the following. I would like you to know the following. Copper chloride, silver chloride, and mercury chloride. All of these things are chlorides of what? All of them are chlorides of what? Are compound of what? Chlorine. They are compound of what? Chlorine. Are you getting me? Mercury chloride and silver chloride. Take note. They are not soluble in what? Water. The reason is that, for instance, hydrogen can displace them because copper chloride, you see copper, you see mercury, you see silver. They are lower than, pay attention, copper, mercury and what? Silver. They are lower than what? Hydrogen, the activity series. Are you hearing me? So they cannot displace what? hydrogen. So these ones are insoluble. But the ones that are soluble, compound of chlorine that are soluble, you see that of potassium, that of sodium, they are magnesium, chiefly calcium. They are highly soluble in water because they can always displace hydrogen. Are you hearing me? But those ones lower in the series, their chloride is not soluble. That of copper, mercury, and what? And silver. Thank you. Sulfur. Sulfur is extracted through what? Fast process. So Jamb students should please take note. Allotropies of sulfur. We have rhombic sulfur called alpha sulfur. We have monoclinic sulfur or beta sulfur. We have what? Rhombic sulfur and what? Monoclinic sulfur. So what's the shape of rhombic sulfur? It's what? Octahedral. And octahedral. And there's one unique property of sulfur for it to form ring. That's S8. Are you hearing me? Each sulfur molecule has what? 8 atoms. Octahedral. So rhombic sulfur has brilliant yellow color, while monoclinic sulfur is what? Amber in color. The shape of rhombic sulfur is what? Octahedral. Monoclinic sulfur is what? Needle shape. Monoclinic is what? Needle shape. Okay. The melting point of rhombic sulfur is 113 degrees Celsius. That of monoclinic sulfur is what? 119 degrees Celsius. For stability, rhombic sulfur is what? Stable below 96 degrees. Stable what? Below 96. And monoclinic is stable between 96 and 119 degrees Celsius. But I want you to know one of the remarkable properties of sulfur is that for sulfur, what happens is that when you're heating rhombic sulfur, you know you heat rhombic sulfur to form monoclinic sulfur. When you're heating rhombic sulfur, when you get to 200 degrees Celsius, it attains the highest form of viscosity. It becomes very thick again. This is because these links, these bonds, when they get loosened, they entangle with each other. When they get loosened, they do what? And become highly what? Viscous. So from temperature of 160, it will start becoming viscous. But the peak of the viscosity is what? At 200 degrees Celsius. Take note. It becomes viscous. So viscous because of the strong bond that exists between it. So what is the color of rhombic sulfur? Okay. Sulfur is stored in carbon 4 sulfide. Sulfur is stored where? In carbon 4 sulfide. Now also take note, sulfur combined with coke in an electric furnace to form what? A colorless liquid known as carbon 4 sulfide. Sulfur is chiefly stored where? In carbon 4 sulfide. Take notes. Now, preparation of sulfur. Preparation of sulfur. Okay. But before then, let's talk about the use of sulfur. Sulfur is used chiefly in vulcanization. Vulcanization. What is vulcanization? What is vulcanization? hardening of rubber is what? The hardening of what? Rubber. Are you hearing me? Through cross linkage, right? Yes, sir. The hardening of rubber. Rubber through what? Cross linkage. That is what? Vulcanization. Sulfur is used in the vulcanization of rubber. That's the hardening of rubber. Sulfur is used in making bleaching agent. A typical bleaching agent is what? SO2. I told you that SO2 bleaches by what? Reduction. The SO2 bleaches out. Thank you. Now, there are compounds of sulfur. One of the compounds of sulfur is what? Hydrogen sulfide. One of the compounds of sulfur is what? Hydrogen sulfide. The apparatus, keeps apparatus. Keeps apparatus is used in the production of sulfur and CO2. Take note. Keeps apparatus is used in the production of what? Sulfur and CO2. This is a sketch of what? The substance here is hydrogen 2 sulfide, that is at this side. This is dilute hydrogen chloride. And this is the channel via which the hydrogen sulfide goes out. Don't forget that Gibbs apparatus is used in the production of what? Hydrogen sulfide and what? CO2. Thank you. Fine, I would like you to know that it has rotting egg smell, right? And it is colorless, very poisonous, and it burns with pale blue flame. One of the striking properties of hydrogen sulfide is it serves as a precipitating agent. It precipitates various metals out of their compound. Are you hearing me? You know, when you talk about precipitation, the substances that are always precipitated are insoluble substances. They are what? Insoluble substance. Whenever you talk about precipitation chemistry, it's a method of separating insoluble substance. There must be an insoluble. You may see two compounds when they react. One of them becomes soluble and the other one becomes soluble. Now, one of the characteristic features of the precipitating nature of hydrogen sulfide is that the various substances of the metals that are precipitated, they have their unique colors. The various substances of the metals that are separated have their what? So two things you could use in qualitative analysis to indicate what kind of metallic sulfide is there. Is based on their solubility, and number two, apart from solubility, it's also based on their color. Take notes. Okay. The following sulfide are black in color. Lead sulfide, when it's precipitated out, is black in color. Copper sulfide, iron sulfide, silver sulfide, mercury sulfide, nickel sulfide, cobalt sulfide. These ones are what? Black. The only one that is white is zinc sulfide. The only one that is white is what? Zinc sulfide. Tin sulfide and cadmium sulfide is what? Yellow. Manganese sulfide is pink. Take note. Manganese sulfide is what? Pink. So based on their solubility, now the sulfide of substance that are high in the activity series, the sulfide of substance that are high in the activity series, they are soluble. Are you hearing me? The insoluble ones are those that are lower in the activity series, like copper sulfide. Thank you. The following sulfide, I told you beforehand that those metals that are higher in the activity series, like potassium, sodium, the calcium, their sulfide are what? Soluble. But those ones that are low in the activity series, like that silver, copper, their sulfide are what? Insoluble. Thank you. So you can prepare the sulfide by neutralization. All soluble sulfide can be prepared by what? Neutralization. The reaction of acid and base. The reaction of what? Acid and base. That's through neutralization. Example of soluble sulfide. They are the sulfide of those metals that are high in their activity series. Can you tell me one of the metals that is high in their activity series? Potassium. Which other one? Magnesium. Sodium. Are you hearing me? So sodium, potassium, and also ammonium. Ammonium salt. Ammonia. Are you hearing me? They are highly soluble. So you prepare them by what? Neutralization. Those ones that are insoluble, you prepare them by precipitation. Take notes. Those sulfide that are insoluble, how do you prepare them? By precipitation. You precipitate them out. Example is what? Silver sulfide, copper sulfide. So let's talk about the uses of this sulfide. Take note. Tin sulfide is used in paint, in making paint. Tin 4 sulfide is used in making what? Paint. In paint. Zinc sulfide is used in the coating of the inside of television screen. Why is it that it's sensitive to light? Zinc sulfide is sensitive to what? Light. That's why if you on your screen, the screen of your television is able to capture image and relay it. So zinc sulfide is used as coating or in the coating of the inside of a television. We have iron 2 sulfide. It will react with hydrogen chloride to produce other sulfide, such as hydrogen sulfide. Okay, don't forget, SO2 bleaches by what? Reduction. SO2 bleaches by what? It is colorless, it is poisonous, and it is very soluble in water. So, SO2 is a good reducing agent. SO2 is what? A good what? Reducing agent. So why is it able to reduce substance? Why is SO2 able to reduce substance? Okay, the ability of SO2 when it dissolves in water, ability to form triosilicates. That's what gives it the ability to, its reducing capacity. Thank you. So we use oxidizing. Okay, we use oxidizing agents. We use oxidizing what? To test for what? Reducing agent. To test reducing agents. Examples of the oxidizing agents. Can you list them for me? KMNO4, MNO2. This is purple. This is purple in color. When it's being reduced or if it oxidizes substance, it will change to colorless. From purple to what? From purple to what? Okay. React with the following oxidizing agents: potassium tetraoxomanganate and potassium heptaoxochlorate, dichlorate, then iron 3 chloride and HNO3 and chlorine. Chlorine is also an oxidizing agent. So we are testing for SO2. What we're dealing with now is what? SO2. SO2 serving as a what? Reducing agent. This SO2 serving as what? Reducing agent. So reaction with potassium permanganate and potassium heptaoxodichromate. It will change potassium heptaoxodichromate from orange to what? To green. It will reduce it from orange to what? To green. This iron 3 will be reduced to iron 2. The color will change from what? Brown to green. When you react with hydrogen triazonitrate, it will release NO2, which is brownish in color. It will release what? When SO2 reacts with what? HNO3, it will release what? NO2, which is brownish in color. It can also react with chlorine too. So these are the reducing property of SO2. Okay. So SO2 bleaches by what? Reduction. SO2 bleaches by what? Thank you. SO4. H2SO4 is prepared through contact process. H2SO4 is prepared how? Through contact process. H2SO4 is prepared how? Through contact process. So, you know, oxygen is added to it to form SO3, which later reacts with what? H2SO4. If you add H2SO4, it serves H2SO4 here in the preparation of H2SO4. The one you add here to this substance is just to dehydrate it. Are you hearing me? It's for dehydration. Are you hearing me? So to form oleum. So after the formation of oleum, it will then finally form H2SO4. Thank you. When it's dehydrated, when this is dehydrated, they give you Cu. When it losses its water, you can dehydrate it using H2SO4 to give you. You know this one is blue. This is what? Blue. This compound, copper tetraoxosulfate, 6-pentahydrate is blue. It's blue in color. This used to test for water. It's blue in color. So when it loses its water, it will turn to anhydrous CuSO4. So what do you use to remove the water? It's H2SO4. Now take note. H2SO4 is a dehydrating substance. H2SO4 is what? Used for dehydration. But you can't use it to dry ammonia because it reacts with ammonia. You can't use it to dry what? Ammonia and hydrogen sulfide. You can't use it to dry ammonia and what? Yes, take note. You can't use it to dry ammonia and hydrogen sulfide. Another feature is that what was the suitable drying agent for drying ammonia? The suitable drying agent for drying ammonia is calcium oxide. You use calcium oxide to dry what? Ammonia. You can't use H2SO4 to dry ammonia or hydrogen sulfide. You use what? Calcium oxide. Now also silica gel is also used to dry all gases. Silica gel is used to dry what? All gases. But the one that is specifically the best for drying ammonia is what? Calcium oxide. Thank you. There are some questions here we need to answer. Extraction of sulfur from the earth crust is by what process? A. Sulfury process. B. Contact process. C. Frasch process. D. Clean process. Frasch what? Process. Which of the following allotrope of sulfur has amber color with needle shape? A. Rhombic sulfur. B. Plastic sulfur. C. Monoclinic sulfur. Flower of sulfur. It's monoclinic sulfur. Which sulfur is heated gradually and in limited supply of air, it develops a feature at 200 degrees Celsius. This feature is what? A. Turn into brown vapor. B. Develop a floral pattern. C. Become highly viscous. D. Turn into amber colored liquid. It become highly what? Viscous. Another feature. Sulfur reacts with many metals when heated in the absence of air, but sulfur reacts with one of these without heating. Which of them will sulfur react with without heating? A. Iron. B. Sodium. C. Gold. So sulfur reacts with sodium without heating because you know sodium is high in the activity series. Are you hearing me? Sodium is what? High in the activity series, so it can react directly without heating. Excess sulfur reacts with hot concentrated sodium hydroxide solution to form what? It will form, let me just answer that briefly. It will form sodium polysulfide and trioxosilicate. Sulfur reacts with soft rubber to harden it by what method? A. Direct linkage. B. Polarization. C. Cross linkage. D. Smoking. Cross linkage. Are you hearing me? I put it on the board. Cross linkage. One of these ionizes slightly in water to form a dibasic acid. One of these ionizes in water to form what? A dibasic acid. Ionizes, I read again. One of these ionizes slightly in water to form a dibasic acid. The answer is hydrogen sulfide. All sulfide are black except A. lead sulfide, B, zinc sulfide, C, mercury sulfide, D, iron sulfide. The answer is what? Zinc sulfide. Zinc sulfide is the only white sulfide. Okay. When copper reacts with H2SO4, a gas is evolved. What gas is that? Sulfur 4 oxide. Sulfur 4 oxide bleaches by A, oxidation, B, reduction, C, decomposition, D, carbonation, reduction. Sulfur 4 oxide is used for this except A, germicide and fungicide, B, refrigerant, C, preserving liquid like orange juice, D, used for storing ozone layer. So the one that's wrong is what? This was storing ozone layer. The property of sulfur used in the extraction by the French process. Why do we use French process in the extraction of sulfur? They say A is because of its allotropic nature, B, unstable nature, C, transition temperature, D, non-metallic nature, E, low melting point. It's because of its low melting point. That's why we use it for French process. Take note, both hydrogen sulfide and sulfur 4 sulfide decolorizes acidified potassium tetraoxomanganese 7. But in addition, hydrogen sulfide produces what? What is it that hydrogen sulfide produces that differentiates it from SO2? What's the difference between SO2 and H2S? The difference is that hydrogen sulfide will deposit sulfur, yellow sulfur deposit. It will precipitate what?